let's learn about 3D shapes and surface area. We're going to go over how to draw them, how to name them. We're going to name their parts, and then we'll look at the surface area formulas, talk about lateral area and surface area. Let's get ready. You're going to need your notes and a pencil and a calculator. Lots of new drawings. We're going to label our drawings, vocabulary, and formulas. So let's compare. I'm going to draw a prism, and in the process of drawing it, I'm going to talk through it so that you can draw it because it is going to be three-dimensional. And then we're going to draw a pyramid and we'll compare them. So I'm going to draw a rectangular prism, which means I'm going to start with my rectangle in the front. And then I'm going to draw the same rectangle diagonally behind it in the back. That's terrible. And then I'm going to connect the corners. And we have our prism. So technically you could ... the ones that you don't see in the back, but that's a prism. So our prism is now three-dimensional. We're going to have a top and a bottom. We're going to have two sides, the right side and the left side. Then we're going to have the back and we're going to have the front. So six-sided figure there. When we draw a pyramid, I'm going to draw let's go with a square pyramid. So I'm going to draw, it's going to look more like a parallelogram because I'm trying to go for that three-dimensional thing. So that is a square. And then above it I put a little dot, and then I draw the dot down to the sides, the corners, and I have a pyramid. So if we are now comparing them, if we look at the prism has a flat top and a congruent parallel flat bottom. So this one has two bases. Then around the outside it would have four faces. When we look at the pyramid, it only has one base. And what we're going to find out is both of these are going to be named by what their base is. So a prism's going to have two bases, a pyramid's going to have one base. And if you notice in the pyramid, we have four triangles, and those are our faces. So thinking about how we name them, and we name them according to their base. Remember, the base doesn't always have to be on the bottom. So if I look at this triangular prism, I have a triangle in the front and a triangle in the back, and then I'd have four rectangles around the side. So it's the parallel pieces that name it. So that's a triangular prism. Then I have a pentagonal prism. I have a hexagonal prism, a square prism, they're all the same sides, rectangular prism, an octagonal prism. Then when we look at pyramids, we said they only have one base, and we name the pyramids by the shape of their base. So this is the base, and it's a triangle. So we have a triangular pyramid. We have a square pyramid. We have, it's a little hard to see, but there's the rectangle on the bottom. That's a rectangular pyramid, pentagonal pyramid, hexagonal, and octagonal pyramid. And then the pyramids all have faces that are triangles. Let's compare and draw cylinders and cones. So the way we draw a cylinder is it does have a circle for a base, but again, because I'm going for a 3D shape, it's going to look more like an oval. So I'm going to start with one at the bottom and try to draw a congruent one at the top, and then you're going to connect the sides. So a cylinder is like a soup can. And then if we have a cone, it also has a circle that's going to look like an oval for the 3D effect. So I have my cone, and like the pyramid, I'm going to put the dot up top and then just draw down. So we have a cone like an upside down ice cream cone. So once we start to compare them, the cylinder has two circle bases and the cone has one circle base. And then if we were to unpeel this all the way around, let's think if it was a water bottle or a soup can, what happens is it comes out to be a rectangle. You unpeel it, so you'd have like a circle here and a circle here. If you rolled it back up, you would get that. So we call this the lateral area. I didn't talk about it in the other shapes, but I think it's easier to see in the cylinder. The lateral area is the area that does not include the bases. Surface area is everything together. But lateral area is basically, lateral stands for side, so it's the area of the sides. So a little more vocabulary with these two shapes. We have our cylinder, we have the height, which is up and down, but keep in mind you can have a cylinder that's lying sideways and then that would still be the height. So the height is the distance between those two parallel circles. And then the radius, remember that's just half the diameter of the circle. In our cone, we have a radius in our circle. We have the perpendicular height that comes straight down the middle. And then we have this new thing, and this is a slant height. So while we call our regular height a lowercase h, we need a new letter to call a slant height, and it is a lowercase, usually cursive L. So that's our slant height coming down. And then we have the vertex up at the top. A sphere. So we're drawing a sphere. We're thinking a ball. We want to make it look like a three-dimensional shape. So I am going to draw a circle. And then the way we make it look three-dimensional is we kind of, if you think about this as the world or the globe, and we pull the equator towards us, and then we dot it back like that. And then I can put that in the middle. And that's supposed to look like a three-dimensional circle, sphere, ball. So within the sphere, we have the red, which is the diameter, the full length apart. We have the radius. Keep in mind the radius can move. It could go there, it could go there, it could go there, it could go down there. So those are all radii. The center of the sphere is right in the middle. And then we have this great circle, and that would be the largest circle that you can get out of that sphere. If you cut it in half, half is hema, so you have hemisphere. And the biggest part, again, would be the great circle. Let's just talk about the parts. So my first shape here, I have a rectangular prism. I'm going to call this one and this one the base, and so that's a rectangle. So those are the bases. And then the side, the top, the side, and the bottom, those would all be the faces. Then we have the vertices, and the vertices are essentially our corners. And usually they'd be labeled with some letters. And then we have our edges, and that's pretty self-explanatory. So this shape here is a triangular prism. We have two triangles, but then notice my faces all the way around are rectangles, so we have rectangular faces. This last shape is a hexagonal prism. I know it's a prism because it has the two bases and they're both hexagons. And then it has 6 rectangles all the way around. So this is the formula. These are the formulas from the MCAS sheet. The S is side. So the lowercase s is the length of the side. Capital SA is surface area. L, the lowercase cursive L, is our slant height. And so you'll have this formula for the MCAS. You'll have it for quizzes and tests. So to find the surface area of a cube, so a cube is all just squares. So if I know one side, I can do side squared because it's the area of the square, and then I have 6 of them. So I have 6 times s squared. And then we're going to look a little closer at the pyramid and the prism because they get a little more involved. So for the prism, remember what we what we might have is we might have the top and the bottom, the left and the right, and the front and the back. So that's what we're going to count for all of here. We have 2 of each of those. So let's go ahead and do a problem. So here I have a rectangular prism. This is 7, which means that this is 7, which means my front is 7. This 2 is the side bottom. This 4 is over here. So I can go through the formula, or I can just think about the shapes myself. I'm going to do the front, the 4 by 7. So I'm going to say SA equals 2 of them, 4 by 7. That's multiplied. Plus, so I did the front and the back. Now I'm going to do the top and the bottom, which is a 7 by 2. So I have 2 of those, 7 times 2. And then I'm going to do this little side. It looks like a square, but a little bit smaller. So plus 2 4 by 2s. Notice I had 3 different numbers, so all of these parentheses should be different if I got all the correct combinations. So then we're going to multiply it out. So I'm going to have 2 times 28 plus 2 times 14 plus 2 times 8. You can do that all on your calculator and you're going to get 100. My units are centimeters squared. So when we find surface area, we're really just thinking about the parts and finding the area of each. Pyramid gets a little more challenging. We do have this slant height that we have to look at. So here I have a square pyramid. I know it's square because both the sides there are 16. The 17 is my slant height, so they gave it to me. That is different from what would be the perpendicular height coming down the middle. So I am going to follow the formula on this, and the surface area is going to be the side, which is 16 in this case, so 16 squared, plus 2 times my side times my slant height. And when I do that out, 16 squared is 256, and all of that multiplied is 544. And conveniently, we're going to get 800 inches squared. And we did it. Nice job.